Hello everyone, I am Sahil and welcome back to our channel. Today we are diving into the one of the most elegant and powerful algorithms in computer science, and that is binary search. If you have ever wondered how Google finds your search results in milliseconds from billions of web pages, you are about to discover that secret today. Binary search is like being a detective with a superpower. Imagine you are looking for the specific page in a 1,000 page dictionary. Would you start from page number 1 and flip through every single page? Of course not. You would open it somewhere in the middle and use the alphabetical order to guide you. That's exactly what binary search does, but with the mathematical precision. By the end of this video, you will understand how binary search works, why it is incredibly fast, and most importantly, you will see it in action with real code. Plus, I will show you visual demonstrations that will make this concept crystal clear. So, grab your favorite drink and let's unlock the power of binary search together. Trust me, once you see how this works, you will never look at the searching the same way again. Let's start with the real problem. Here is a sorted array of numbers and we want to find number 23. Okay, with a normal search, we will check each element one by one. That could be take total 12 steps and that is the worst case. In the linear search, we have to check each element one by one and that concludes in the 12 operations. But binary search is smarter. It uses the fact that our array is already sorted. Think of it like playing a guessing game where someone says higher or lower after each guess. That simplifies the process. Here is how it actually works. We start by looking at the middle element. Our array has 12 elements. So the middle is at the position 6. That's the number 38. Okay, first we have to check is number 23 is equal to number 38. The answer is no. Is number 23 is less than number 38? The answer is yes. This tells us the something most powerful, that 23 must be in the left half of from the number 38. So we can completely ignore the remaining right half. Okay. Now we looking only in a left half from the number 38. Okay, now repeat the process with just the left half. The middle of the left half is now number 12. Now we have to check is number 23 is equal to number 12. The answer is no. Then we check is number 23 is greater than number 12. The answer is yes. So now we took only the right part of the remaining section and wipe out the left part. We keep cutting our search space in half until we find our target, that is number 23. Look at how fast is this. In just 3 steps we found our number 23. Compare that to potentially 12 steps taken with a linear search. This is when binary search becomes amazing. For an array consisting of 1,000 elements, linear search might take 1,000 steps, but binary search will find any element in at most 10 steps. For a million elements, linear search takes up to 1 million steps, but binary search just 20 steps maximum. Okay, the secret is in the math. Each steps elements half of the remaining possibilities. This gives us the complexity of only O log n, which is incredibly efficient for large data sets, and binary search is an efficient searching algorithm for large data sets. Okay, now let's see the binary search in action with real code. I am using Python because it is clean and easy to understand, but this logic works in any programming language. Let's see our program. Okay, let me walk through this code. We start with 2 pointers, left at the beginning and right at the end. In our while loop, we calculate the middle position. If the middle element is equal to the target, means if the middle element 38 is equals to the target, then we are done. We found our element. If it is smaller than our target, if 38 is smaller than 23, we move our left pointer, move it to the left pointer. Okay, and if it is larger, we move it to the right pointer. Okay, watch what happens when I run this with our example. Okay, if I run this program, look, perfect, it found 23 at index 5. The beauty of this algorithm is its simplicity and power. Just remember, binary search only works on a sorted data. Means the data must be sorted when using the binary search algorithm. If your data isn't sorted, you will need to sort it first or use the different search method like linear search. And that's the binary search, from the detective work to the code implementation in just 5 minutes. If this helped you understand the concept, smash that like button and subscribe for more computer science explanations. What algorithm should I cover next? Let me know in the comments below. Until the next time, keep coding and keep learning.